Hi there. Let me take some time and take you through example 3. I think this is an important one because we're going to review how to use the calculator commands to calculate binomial probabilities. So let's start by assuming, and I just made this up, that randomly selecting a Westfield resident who supports the Affordable Care Act, or ACA, that probability, we'll call it 0.41, and that support is independent from person to person. So notice, if I want to calculate the probability that 3 out of 8 randomly selected residents support the ACA, we can do this using a binomial distribution. I'm sorry that this got cut off here. So notice, what I'm suggesting is that X is distributed binomially, B for binomial, where N is 8 and P is 0.41. So in terms of this notation, this is N, that is the fixed number of trials, and this is P, the success probability, which is fixed. And of course, the B stands for binomial. So here's why there are 4 conditions that you need to verify in order to know that this is true. So there have to be 2 outcomes, and there are here. You either support the Affordable Care Act or you don't. Number 2, there's a fixed number of trials, and in this case, there are only 8 trials. We're selecting 8 individuals, and we're looking for the probability that 3 out of those 8 support the ACA. So the probability of success is fixed, and in this case, that fixed probability is 0.41. And then lastly, something that I assumed up here, independence. Outcomes are independent. So whether one randomly selected person supports the Affordable Care Act is independent of whether another randomly selected person supports the ACA. So the outcomes are independent. These are the 4 conditions needed in order to use a binomial probability model. So X here represents the count, the number of individuals out of 8 who support the ACA when they're randomly selected from Westfield residents. So here, the probability that X equals 3, something to think about. It is important in your exam, if you were to do a free response question that uses binomial probabilities, it's important to indicate you understand that the situation is binomial. You should indicate the fixed number of trials. You should indicate the fixed probability of success. This is notation that we used in class. This is perfectly acceptable on the AP exam. But then it's also important to be specific about the events for which you're trying to find the probability. So this is the probability that X equals 3, the probability of a count of 3. So beyond that, you can do the rest of this in your calculator. So under second variables, notice it's been a while since we've done this. If you scroll down, you will see the binomial PDF and CDF. So binomial PDF, when you use this command, the first thing that you enter is the number of trials, that is 8. Then you enter the probability of success, that's 0.41. And then after that, you enter the specific value for which you're trying to find the probability, and that's the event X equals 3. 3 out of 8 randomly selected individuals support the Affordable Care Act. That probability is, we'll call it 0.276. So that probability is approximately 0.276. So notice the probability that X is not equal to 3. Notice we already found the probability that X equals 3, so this is the complement, the probability that X is anything but that. Well, that would simply be 1 minus the 0.276. Let's see what that is. That's 0.724. Notice we don't want to take the time separately to find the probability of the outcomes X equals 0, X equals 1, X equals 2, 4, 5, 6, 7, and 8. We've already accounted for that by just using the complement. Now, here, the probability that X is less than or equal to 3. So here we're looking for an entire range of options. So this actually includes, you don't normally have to take the time to write it out, but I'm going to do this. This includes the probability that X equals 0, plus the probability that X equals 1, plus the probability that X equals 2, all the way on up to the probability that X equals 3. So if you wanted to, you could use the binomial PDF command and calculate all 4 of those outcomes separately. Or you can use the binomial CDF command, C standing for cumulative. So the way the command works in your calculator, second variables, back down to binomial CDF. There it is. So it's pretty easy to work with. So the first thing, again, that you enter is the number of trials. That is 8. Then you enter the fixed success probability of 0.41. And then we are interested in the probability of x equals 0 all the way up to and including 3. So I will include the 3 as my upper boundary and press enter. So the sum of all of those probabilities will take us to 0.571. So that's literally the probability of x equals 0. So no one out of the 8 supports the ACA, plus the probability that only 1 does, plus the probability that only 2 does, plus the probability of 3. So we have added all of those up. That's what C stands for, cumulative. We have accumulated all of those probabilities in the 0.571. So notice something special here in this question. I want to find the probability that x is less than 3. Now be careful. That means I don't want to include the outcome of 3. So this includes 0, 1, 2, and 3. I don't want to include 3, so I need to take away from it the 0.276. So one way to find this probability would be to just take the 0.571 and subtract away the 0.276 that I already found. That's 0.295. But I want to verify that for you, so let's be really specific here. The probability that x is less than 3, that is the same as the probability that x is less than or equal to 2. Less than 3 means we're only looking at the outcomes x equals 0 plus x equals 1 plus x equals 2. I don't want to include 3. So we could also do this question by using the binomial CDF command. The only difference is I want to stop at 2. So I can go here to binomial CDF again. Again, 8 is n. P is 0.41, but I don't want to put in 3 for my boundary. I want to put in 2. I only want to include the outcomes 0, 1, and 2. And there's the 0.295 again. There we go. So you have to be careful when you are looking at a binomial distribution. There is a difference between less than or equal to 3 and strictly less than 3. That's why I did those two questions. So please don't think too hard then. The nice part is the probability that x is greater than or equal to 3. So understand that's simply the complement of this, the probability that x is less than 3. So understand x being less than 3 includes the outcomes 0, 1, and 2. This includes the outcomes 3, 4, 5, 6, 7, and 8. So essentially all we need to do is take 1 minus the 0.295. We've already done the work. 1 minus 0.295, that gives us 0.705. And I believe we're done. Hope this has been helpful.